Hi viewers, welcome to our channel Math and Math. So today we will be solving a Csir Net problem, and this is a part B question, so therefore only one option will be correct. So here the question is, let P be a polynomial of degree k greater than 0 with a non-zero constant term, and let Fnx is equal to P of x by n for all x belong to the open interval 0 to infinity. Okay, then four options are given. Limit n tending to infinity fn of x equal to infinity for all x belong to 0 comma infinity, or option B, there exists an open interval x belonging to 0 comma infinity such that limit n tending to infinity fn x is greater than p of 0. The other option says limit n tending to infinity fn x is equal to 0 for all x belonging to 0 to infinity. The last option says limit n tending to infinity fn x is equal to p of 0 for all x belong to 0 comma infinity. So let us try solving this problem. So first let us take a polynomial p of x and then continue to solve the problem. So solution, let us consider the polynomial p of x to be equal to x to the power k plus a1 into x to the power k minus 1 plus a2 into x to the power k minus 2 plus so on plus a k minus 1 x plus a k. Okay. Now this is a polynomial of degree k greater than 0 with a non-zero constant term. Okay. So this is a polynomial with a non-zero constant term. So from this polynomial we can take fn x is equal to p of x by n for all x belonging to 0 comma infinity. So what will be p of x by n? So this will be equal to x by n to the power k plus, here in place of x we are replacing x by n, that's all. So x by n to the power k plus a1 into x by n to the power k minus 1 plus a2 into x by n to the power k minus 2 plus so on plus a k minus 1 x by n plus a k. So this is again for all x belonging to 0 comma infinity. So for all x belonging to 0 comma infinity, this polynomial exists. Now let us take limit n tending to infinity. This implies limit n tending to infinity fn of x is equal to limit as n tends to infinity each of the terms. So let me write it as x by n to the power k plus a1 into x by n to the power k minus 1 plus so on plus a k minus 1 x by n plus a k. So this is equal to limit as n tending to infinity x by n to the power k plus a1 into limit as n tends to infinity x by n to the power k minus 1 plus so on plus a k minus 1 limit as n tending to infinity x by n plus, here you have only a k. Anyways, let us write it as limit n tending to infinity a k. So in each term if we see here and all the terms where you have n, as n tends to infinity, here we have x by n to the power k. So as n tends to infinity, anything by infinity, that is 0 to the power k, so that will be 0. So all the terms which has n here in the denominator, that goes to 0. So this will be the first term 0, second term is 0, plus so on plus up to the last second term, it is 0. What about the last term? The last term does not contain n, so this will remain as it is as ak. So this is nothing but ak. So now from our polynomial which we had considered, p of x, so if you check p of x here, so over here in this equation star, if you check for p of x, when you will get ak, when you have x 0, when you substitute x as 0, here this term will be 0, this term will be 0, all the terms will be 0 except the last term, that is ak. So p of 0 is nothing but ak. So therefore we have ak as nothing but p of 0. So this is for all x belonging to 0, infinity. So therefore limit as n tending to infinity, fn of x is equal to p of 0 for all x belonging to 0, infinity. So therefore which option is right? Let us check for the options. So here if we see, we got limit as n tending to infinity, fn of x to be equal to p of 0. So this is wrong and this is wrong, this is also wrong. So only option D, limit as n tending to infinity, fn of x is equal to p of 0 for all x belonging to the open interval 0, infinity. This is the correct option. So option D is the only option which is right, and this is a part B question, so therefore only one option is right. So option D is the correct answer. Thank you.